Good evening, everyone. I'm Alan Fisher. On this episode of AZ Illustrated Science, join us in the Catalina Mountains where students gain hands-on experience with science. Also, later in the show, we have some fun with chemistry. But first, here's a look at today's top stories.
The Arizona Department of Transportation is holding a public meeting tonight on traffic changes to Interstate 19 and Ajo Way. During the meeting at the El Pueblo Neighborhood Center, ADOT officials will present plans to rebuild the I-19 Ajo interchange. The public will have a chance to comment about the proposal, including the possibility of building soundproof walls to buffer homes from traffic noise. Crews are scheduled to start work on that project in 2015. Election Day is still a year away, but the ads are beginning. Congressional District 1 candidate Andy Tobin is running a radio ad in parts of the district which stretches from Oro Valley in the south to the Utah-Arizona border. Even though he's one of 3 Republicans running for the seat, the ad is squarely taking aim at Democratic incumbent Ann Kirkpatrick for her support of the Affordable Care Act, more commonly known as Obamacare. National Republicans began attacking Kirkpatrick as soon as she was elected. They view her seat as one of a handful of vulnerable offices they can pick off in November. The ad will run for about a week. Campaign officials would not disclose to AZPM the cost of that ad run. The U.S. Ninth Circuit Court of Appeals is about to begin streaming arguments on the internet. The cases next week will mark the first time a federal appeals court has allowed the public to view arguments live online. When asked why the court was putting the arguments on the internet, the chief judge of the Ninth Circuit told AZPM, quote, "because we could." He also says the Ninth Circuit Court of Appeals is a public institution. The court is expecting to stream about 20 days of hearings a year. And that's a look at tonight's headlines.
The UA Science Sky School provides K-12 students with an opportunity to learn about ecology, geology, and astronomy. Students get an interactive experience in the unique environment of the Catalina Mountains as they make their way up to the Mount Lemmon SkyCenter. Producer Yoo-Hyun Jung and photographer Andrew Brown take us to Mount Lemmon for more.
My name is Julia, and when I grow up, I want to be an interior designer.
I want to be a basketball player.
I want to be an actress.
An aviation officer.
Emergency physician in the Air Reserve.
These children from the Flowing Wells School District Center for Academically Talented Students have many different dreams that are not related to science, but they have many more years to decide what they want to be. Until then, they are open books.
I'm Ryan, and I want to be a geologist when I grow up.
Can anyone else tell me where...
Ryan is a curious kid who likes rocks of all kinds, whether they're from this Earth or space. At UA Sky School, he'll be able to learn about both.
What did you write?
Pine trees, they...
The UA Sky School is an outdoor learning experience run by University of Arizona graduate students. It brings K-12 children out of their schools and into the wild to expose them to different fields of science. The Sky Islands environment on Mount Lemmon is the classroom, with nature and the open skies as its bookshelves, containing infinite amounts of knowledge.
Sky Islands are really special because there's a really interesting geologic story here about why the Sky Islands are in this region. The ecology changes as we drive up the mountain. Biologically, it's like driving from Mexico to Canada in just 30 miles. That's a great learning opportunity. Elevation and air pressure.
Despite the name Sky School, the sky isn't the only thing kids can learn through the program.
Do you guys know the elements of a hypothesis?
The day begins at the Baba Doak Trailhead, 2 miles up the mountain. Sommers says through exploring the nature that surrounds them, they are learning to develop scientific habits like observing and documenting data.
The basis of science is asking questions about the world around us. And if kids aren't connected to the world around us, if they're not noticing the world around us, making observations about nature, enjoying it, they're not even going to ask questions. So in the first place, just being up here, seeing something new, and making those deeper observations than if they just came up for a day hike with their family, allows them to start asking questions and interacting with this environment and inspiring scientific thought and critical thinking in a whole new way.
Children take measurements of temperature, altitude, and air pressure in 3 different locations on Mount Lemmon, each one a bit further up than the previous. As they make their journey up the mountain, students witness how the ecology changes with their own eyes. Their final destination is the SkyCenter campus at the summit. There, the students get a chance to explore scientific phenomena not so close to home.
And we have the astronomy resources up here to tie all of that into a larger sense of our place in the universe and relate that, what we learn here about geosciences, to what we can see of the meteorites that the Catalina Sky Survey up here detects every night.
Ryan, who likes rocks, is observing a flaming space object, the sun.
I see 3 sunspots that look like a happy face.
You see these lines? That's exactly what sunspots look like.
Sommers says Mount Lemmon is an ideal place to study astronomy because the mountain sits high up and the surrounding areas are lowlands. The summit is not as disturbed by light pollution.
I see like little splotches coming off the sun.
The day is approaching an end. There are overnight programs at UA Sky School, but the students are returning home in the evening. One of the last activities to end the day is to put what they saw and experienced together with theories.
It's just a great experience, and it gets them outside, outside of the classroom, which a lot of these kids need. They're so used to doing everything on the computer or seeing everything on a screen, and to get them outside in the environment and to show them, leaves changing color. And this is what kids need. They just need to be outside seeing what they're studying. It's so important.
She says many of the students graduating from the Flowing Well School District are first in their families to go to a university. So it's important for them to interact with college students like Sommers.
Does anyone else have some observations that are similar or different?
What happens is it breaks up in
Sommers says not only does the program benefit children learning science, but it also benefits the grad fellows who are teaching it.
Well, it's a great opportunity to learn how to talk to age groups other than undergraduates.
Okay, so that's a great observation.
A lot of graduate students end up as teaching assistants at some point in their graduate career, but even those undergraduates are a little bit different than the general public in terms of their expertise, experience, and attitudes. Once you can talk about your research to a 7th grader, you can talk about your research with a much broader spectrum of the population.
She says she is also fulfilling her own dream while exposing children to their potential dreams.
To be that person who can put science and outdoors and exciting in the same sentence and have that make sense for a student who's never been up to Mount Lemmon before, never been hiking before, is really exciting for me.
While most geology research happens here on Earth, one University of Arizona student took her studies to space. Joining me in the studio today is Shaunna Morrison, a UA Ph.D. student from the Department of Geosciences. Last month, Shaunna co-authored 2 publications in the journal Science about her recent discoveries on Mars. Shaunna, thanks so much for joining us today.
Thank you for having me.
Shaunna, you're a member of the science team on the Curiosity rover. Could you tell us a little bit about the instrument on which you're working?
Certainly. It's called a ChemIn, which stands for Chemistry and Mineralogy. It's an X-ray diffractometer, which is actually the first one that's ever been in space, which is really exciting. With X-ray diffraction, you can analyze a mineral, which is what comprises dirt or rocks in general. At least a good portion of it is made of minerals, crystalline materials. So with the X-ray diffractometer, you can actually analyze these minerals and definitively see what they are. So we actually, for the first time, really know what we have. Other instrumentation can sort of tell what it is, within a range, but with ChemIn, you can actually say, okay, I know we have olivine. Okay, I know we have a clinopyroxene. And so it's pretty exciting to actually be able to say, we know what we have.
And are the materials tested actually going into the instrument?
Yes, absolutely. Yeah. So we have 2 different methods of gathering sample, and that's one is to scoop, and the other is to drill. We actually drill and take the drilled fines, and both of those we use the arm to deliver to our instrument, and it just drops sample down into one of our cells. It's about the size of a baby aspirin, the amount that that it drops in there. Very small amount, but just drops it right in there, and we analyze it actually in the instrument.
Great. And as far as the stories that you had in science, could you tell us a little bit about the results from those papers?
Yes, absolutely. So those were based on the rock nest soil or sediment that we analyzed. We have to be careful about using the term soil because sometimes that can imply that there's organic material, and we haven't seen that, so we call it a soil, but we haven't found organics there. So it's a windblown sediment, something like sand, and so Kemen analyzed that. That's the first samples that we analyzed. And actually on the cover of the science paper, where you're seeing the selfie of the rover, if you look down at the base, you can see where there are little areas. I think it's 3 or 4 is what it shows, little scooped out areas where it's darker. And that's actually where we took the rock nest sample. So on the cover, you can see where we sampled it, which is pretty neat. And so we found with those samples that it had a mineralogic composition pretty similar to a basaltic sand that you would find on Earth, which was pretty exciting. A lot of people use Mars as an analogy for Earth, for earlier Earth, and so to find that it lined up pretty well was exciting. So it would be similar to what you would, find on like a beach in Hawaii, a basaltic sand. Of course, again, minus the organic material that you have on Earth, but yeah, it was pretty exciting.
How does relating what's going on Mars versus what's going on Earth benefit science?
Well, obviously we have Earth in the state that it is now. We can't just rewind and see what it was, millions of years ago. So having Mars, which is a smaller planet and therefore it's less differentiated, you have a lot of basalt. On Earth, you have a lot of granite, which is a result of being an older planet and just being around longer and magma differentiating more. So we've sort of gone through that process, but Mars really hasn't. Although there may be a little bit of that sort of material there. It's mainly basalt, which is an earlier material. So it gives us the opportunity to look at perhaps what our planet was like, millions of years ago, way before humans were ever here, way before animals were ever here. So it gives us a sort of a snapshot, frozen in time.
So we can learn more about Earth based on the history of what we're seeing on Mars with your instrument.
Absolutely, absolutely.
Great. And you mentioned organics and so forth. Is your instrument equipped to find organics on Mars?
No, Kemen isn't. That's more so the SAM instrument, which is another very powerful instrument on the rover. And so they are continually looking. Again, we haven't found that. SAM also looks for methane. That was a big story that we analyzed and didn't find methane, although it's been remotely sensed with other instrumentation on board other spacecraft. We didn't see it in the particular location we're in. Doesn't mean it's not there, but SAM didn't see it. And so SAM is the one that would really do that. Kemen is looking at the crystalline material. We can also look a little bit at the amorphous material, but we really need like an internal crystalline structure to be able to see what it is, and organics really don't have that.
And Shaunna, I understand that you're also involved in operating the instrument here from Earth. Could you tell us a little bit about that, please?
Yes. So I'm what's called a poodle, which is a really nice term that we like to laugh about. It's a PUDL, which stands for Payload Uplink Downlink Lead. On the uplink side of it, I actually write sequences of commands to send to the rover, and we actually tell it what to do. So I actually operate it and say, prepare to receive a sample, and then once we have a sample in, I say, okay, analyze the sample, and then put out, this data. And on the downlink side, I actually receive the data and from the transmission from Mars, and that part's not as exciting. I really like operating the instrument. It's really neat to work with the whole team. You're doing it with the whole team together, so it's really, really interesting.
Well, Shaunna, thanks so much for joining us here today.
Thank you.
At the headquarters of BuzzFeed, rooms are named after famous internet cats.
Birthday cat, business cat.
Now the site wants to be taken seriously, too.
We realized we didn't have news, we didn't have reporters, we didn't have any of the kinds of things that were increasingly shared across the social web.
BuzzFeed invests in journalism on the next morning edition from NPR News.
Cochise College's Aspire program makes sure rural kids have the opportunity to explore STEM fields. Outreach Director Ben Berry is here to tell us more. With him is Bill Bosworth with the Science Alliance, a Wisconsin-based group touring Arizona as part of the Aspire program. Bill and Ben, thanks so much for joining us today.
Thanks for having us. Thanks for having us.
Ben, would you tell us a little bit about the Aspire program, please?
Sure. Aspire stands for Arizona STEM Pathways in a Rural Environment. We, with gracious funding from the Arizona Public Service Foundation, we managed to be able to contact Bill, have him come down and put on a series of shows in Cochise County schools that are aimed at the first and the second grade, really trying to get it with the kids early, get them young, get them excited about science so that hopefully they'll pursue that as they go through their K-12 education.
And Ben, how critical is it to get kids interested in STEM topics at an early age?
Very critical. We have a couple of programs at Cochise College, 5 principal programs that address K-12 all the way now from first and second all the way through the high school. And the idea that we have is very simple. We want to hit them often, we want to excite them often, and we want to continue with them throughout through their K-12 education.
And Ben, how can you make math cool to kids?
Well, there's numerous things that you can do to make math cool to it. First of all, you got to put the practical end of mathematics in with it, which is where Bill and science comes in. You know, science is applied mathematics. And so by showing them these and then later getting to the mathematical principles and concepts behind it, it's a no-brainer.
And Bill, would you tell us a little bit about the Science Alliance?
Well, I taught high school chemistry and physics in Lake Geneva, Wisconsin for 10 years, realized a need to get out and get to the kids before they got to high school. You really can't change pathways on kids in high school, so you have to get them at an early age, like Ben was saying, K through 2, and I do only K through 8 programs, and it's all student participatory. As you'll see here in a minute what we're going to be doing, the kids do. And so I draw them in, get their hands wet and sometimes slimy, because we make flubber, and the kids will make super balls, and they'll make all kinds of things which they end up getting to take back to the classroom, and that way the whole school is purely motivated, real motivated. It's a great experience. So.
And Bill, do you travel the country doing this?
Yeah, we really do. We do about 300 shows, and that's about as much as I can handle. I got 2 guys that work for us, and they're actually in Chicago this week doing shows. But up to this point, we've done about 23 years, and we do 300 shows. We're approaching 1.4 million kids that we've been in front of to just purely motivate them, showing science is fun, there's careers. Middle school, we talk more about careers. At K through 2, we will get them excited, so they run into the library and they check out every library book that is on science. So it's wonderful.
And Bill, what makes a demonstration interesting to kids? I mean, is it explosions? Is it fire? Is it smoke?
Well, you know, I learned real quickly as a high school teacher, you could get up and talk to them and put them to sleep. You get them involved, and all of a sudden, you know, the energy on both sides, student and teacher, elevates to a degree that is amazing. And what's really fun about this is all my shows, all the kids, I get between 60 and 70 kids up involved as volunteers. They're doing all this stuff, and I just make sure it's done correctly and the explanations are correct. So it's really a hands-on kind of approach, and that's what we need. We used to be #1 in the world as far as science education, and now we're 23rd. And we used to produce the best engineers, the best research chemists, the best doctors, and it's got to start, as Ben said, in a K through 2 level.
And that was exactly why Cochise College engaged in STEM programming a few years back. And again, the Aspire program for the first and second graders, the early elementary, is one of our 5 programs.
And Bill, you've brought a couple of experiments for us to see.
Sure, I brought a couple of
could you explain what we've got going on here?
Favorite things, yeah. We've got a solution of hydrogen peroxide and a little bit of manganese dioxide. Ben, go ahead and toss that in there. It's kind of fun. And
see you standing back.
I am standing back, yes.
This is sort of a chemical genie that we start out of there, and it'll grow and get a little bit bigger. I also, Ben, I got a balloon down there. brought a balloon along today, and the kids like this a lot, and it gives me a chance to talk about temperature and volume.
I will say, right about here is when the squealing from the first and second graders begins.
Excellent.
But we talk about what happens when I put an inflated balloon into an oven. It's going to pop, of course, because of hot temperatures get those molecules inside going faster and faster. And but what happens then is if we put it into something cold, for example, liquid nitrogen. If I put the same balloon in here for just about 10 seconds, pull it back out, it looks like it's popped. But as soon as you warm it back up, give it some heat energy, get those air molecules going again, which is primarily nitrogen, makes up 3/4 of our atmosphere. It reinflates, so the kids can see as temperature goes down, volume goes down, temperature goes up, volume goes up. Well, Alan, I've got one last thing that's going to require some safety glasses.
Okay, very good.
We stress safety, and certain things we need safety glasses, certain things we don't. But if I can have you just pour a little bit of this in there, and I'll take this from you.
Okay.
And this is kind of a fun chemical reaction. That should probably be enough. We talk about different kinds of chemical reactions that change colors, fizz, foam, some liquids turn into solids, and
that one.
All of a sudden we get something that gets a little bit crazy.
Great.
You might want to move your clipboard.
Okay. Well, Bill and Ben, I want to thank you both very much for joining us today. And to see more cool science demonstrations, visit our website at azpm.org. Earlier in the show, we learned about a K-12 program that takes place at the Mount Lemmon SkyCenter. Now we'll find out what other astronomical things are taking place on this mountaintop. Here with me now is renowned astrophotographer and founder and manager of the UA Science SkyCenter Public Observing Programs, Adam Block. Adam, thanks so much for joining us here.
Oh, thank you very much for inviting me.
And first, congratulations on your being named the Royal Observatory Astrophotographer of the Year.
It's great to get that kind of recognition for work that you do, and it's all part of our public programs at the SkyCenter.
And Adam, can you tell us a little bit about what's going on at the UA Science Mount Lemmon SkyCenter now?
Well, we've been operating now for about 5 years, and in this time we're inviting the public to come up to the mountain and have an opportunity to look through the telescope, basically to have access to the universe. So one of our programs is a nightly one in which people get to look through the telescope and experience the Sky Island mountain of Mount Lemmon. We use star charts and binoculars. Even food is included in this program. It's a 5-hour presentation. So this is like an immersion experience to be able to participate in this show.
And the participants, are they able, Adam, to actually do the things that you're doing with the telescope and images?
Well, there are many ways to use the telescope. One way is the way that we do in these early programs, which is to look through with our eyes, to see through the telescope. But you can attach a sensitive CCD camera, digital camera, to the back of the telescope and capture images of the universe. That is another way to use it, and it is also something that we specialize in at the SkyCenter.
And Adam, you've brought some images for us. Could you please describe the one that we're seeing right now?
Yeah, these images are taken with a very sensitive camera atop Mount Lemmon at an excellent site. So these are some of the very highest quality images of space that you can get. Here is my most recent image, in fact. It's of a nebula called IC417. It looks a little better than its name, I hope. It's a place in which stars are being born. And you can see some of the, not only the vibrant color, but even these details are rarely captured with this kind of fidelity. So this is a great way to get people excited about the universe. When I do these programs at the Mount Lemmon SkyCenter, I can only do the public outreach for as far as my voice will carry. These images have much greater reach because once published, they can be seen by people around the world.
And Adam, can we look at the next image you've brought, please?
Sure. An image like this, again, kind of captures the idea that the universe is vast and there are some strange things out there. You can see stars, a background galaxy, and something in the foreground. Just like we have clouds in our nighttime sky, or even daytime sky on Earth, there are clouds in our galaxy, which kind of block our view. So this is a cloudy area of the galaxy with just kind of latent dust clouds floating around, obscuring the view of the background universe.
And Adam, how far would this be in light years from Earth?
Well, the foreground clouds may only be a few hundred light years away. The background galaxy, some odd millions of light years away.
And what are we looking at in this picture, please?
Well, I think this image better kind of illustrates the other ways in which we can take advantage of the telescope. Once the public observing program completes, the telescope is continued in its usage throughout the rest of the night. And people around the world will basically request observations be made in order to either do science or to take some of these pretty pictures. This is a scientific one in a way, although it's one that I was lucky enough to work with. It's data that I took of a galaxy. It's actually the collision of two. And the arrow points at a star that you don't see in the other older image on the right. And that is not a star in our own galaxy. Instead, it's a star that blew up in that faraway galaxy. It is a supernova explosion. So I discovered a supernova, which was pretty cool, in another galaxy.
Had you done that before, Adam?
No, that was a first. I've been doing this for a very long time, and that's a kind of a first for me. But that has some scientific merit. So those observations I sent to the appropriate people to make measurements and learn more about the galaxy and so on.
And the next image that we're looking at, what would that be?
Well, these images again are of things that are popular today in astronomy and science. So one of those would be an image like this of Comet Ison. And this you should, I guess, look at because no longer does it look like this. It basically fell apart as it went around the sun. But other images, like the next one that we'll see, is a picture of a very faraway galaxy. This is a galaxy that's on the order of 3 million light years away. And what's remarkable is that although it's seemingly very far away, it is a nearby galaxy as far as galaxies go, and you can start to resolve individual aspects of the galaxy. Not only some of the very brightest stars, but some of the nebula in this other galaxy has detail. And so learning more about our nearby neighbors as well as the very furthest things is exciting for the public to be able to do.
So an image like this would both have artistic and scientific applications.
Yeah, although astronomers in general do not spend time taking pictures like this because the data that they acquire is not going to sample all of the wavelengths of light. Whereas in these images, these are called broadband images, which allow us to see the full spectrum of light, and that gives us all of the colors. This is analogous to what if our eyes were as sensitive as the camera that are used, and you could expose for as long, what we would see. So these are the true colors of these objects. Here on the screen is a picture of faraway galaxies, tiny little fuzzy blobs, but those galaxies are no closer to us than around 300 million light years away. So these images, they speak a visual vocabulary of detail and color and contrast. They are more than just simple portraits of swirling gas and stars. They speak of stories, of the lives and deaths of stars, of how entire galaxies orbit each other.
And Adam, we have about 30 seconds left. How broad is your reach with these images? I mean, where are these images found?
The images are often published on very popular sites like NASA's Astronomy Picture of the Day that's seen by millions of people around the world. And in addition to our own website, which I would encourage people to visit and see more of these images, we have hundreds of them, you can visit us on Facebook. And every time we take a new picture, if you want to be the first person in the world to potentially see a picture of a new nebula or some other galaxy, join us there.
Well, Adam, thanks so much for joining us with these fascinating images.
Thank you very much for inviting me. This was a lot of fun.
That's our show. To post a comment on any of these stories or to keep up with the latest news, go online to our website at azpm.org. I'm Alan Fisher. Thanks for watching.